Hey class, throughout this video, if you want to take notes along with me, that would be a great way of storing this information down on paper so that when you go to do the assignment, it's there for you. But today we're going to talk about how to simplify radicals. Alright, and when we talk about radicals, we're talking about this symbol right here. So sometimes it's a square root sign, but sometimes there's a little 3 there indicating that it's a cube root. Or sometimes there's a 4 there indicating that it's a fourth root. But whenever you see this little thing, it looks kind of like a division sign, it's called a radical. So today we're going to just deal with square roots. So we're going to start with some perfect squares. And we call these perfect squares because they come out nice and pretty. For example, the square root of 225. You may not know it off the top of your head, but it does come out pretty. It's 15 times 15. So the square root of 225 is 15. The next one, we have the square root of 36x squared. Well, we know the square root of 36 is 6, and the square root of x squared is just x, because x times x is x squared. All right, and then in our last example, the square root of 16 is 4. The square root of a to the 4th is a squared, because a squared times a squared is a to the 4th. And the square root of b squared is just b, because b times b is b squared. You're basically dividing those exponents by 2 on the variables. Alright, so these are all examples that came out nice and pretty. But what we're going to do today is we're going to simplify radicals that don't come out nice and pretty. And when we do this, what you cannot do is you can't just type it into your calculator and give me a decimal answer. That's what we used to do. Now we're going to simplify radicals, so our final answer will also be a radical. We're going to start with the square root of 75. And before, you might have said, okay, there's no number that I can multiply by itself to get 75. So let me just type in that answer, and we get about 8.6, 8.7. All right? But that's not what we're going to do anymore. So what we're going to do to start is we're going to make a factor tree for 75. So two numbers that multiply to 75. So I'm going to start with 3 and 25. And then 25, I know, can be broken into 5 and 5. So all the prime factors of 75 are 3, 5, and 5. So here's where I call it radical jail. So right now, this 75 is trapped in radical jail. And the goal is to break as much of those prime factors out of jail as we can. And we have 3. We have 3, 5, and 5. But to break out of jail, you have to have a buddy. You can't break out of jail on your own. So if we look at 3, 5, and 5, the only one with a buddy is 5. So 5 and 5 get together. They decide they're going to break out of jail. The problem is breaking out of jail is messy. So yes, one of these 5s will escape and be on the outside of the radical, but the other 5 gets killed on their way out. This took one for the team. All right. So this 5 escaped, this 5 died, got shot trying to escape. But this 3 didn't have a buddy, so it gets left inside the radical. So when I say have a buddy, basically that just means, are there 2 of the same number? If there are 2 of the same number, they buddy up. One breaks out of jail, but the other one dies. All right? So 1 5 was part of our answer, the other 5 was not. Let's try a couple more. Let's try the square root of 252 next. And I'm not sure all of the factors of 252, but I know it's divisible by 2. So when I start my factor tree, I know that 2 goes into 252. And it's 2 times 126. Alright, so that's my first. Then I'm going to deal with this 126, and I'm going to say that is 2 times 63. Alright, and 63, I know that can be broken up further. Let's do 9 and 7. 9 is 3 times 3. Alright, so let's look at all of our prime factors. We have 2 2s, 2 3s, and a 7. And if it helps you to write that off to the side, we have 2 2s, 2 3s, and a 7. Because sometimes it's a little bit easier if we just write it right there. So we know these 2s. The 2s buddy up. But remember, 1 died. The 3s can buddy up, but 1 died. And the 7 doesn't have a buddy. So the 7 is going to be left on the inside of jail of the radical jail. But the 2 and the 3 both escaped. And so because they both escaped, we're going to do 2 times 3. That means a 6 goes on the outside. So our answer is 6 root 7. So the cool thing about this is it doesn't matter how you do the factor tree, you'll still get all the same prime factors. So when I look at the square root of 90, I immediately see 9 times 10. But you might have seen 2 times 45 or 3 times 30. It doesn't really matter how you do your factor tree, your final answer will still be the same as 9. Alright, so then 9, we have 3 times 3. 10 is 2 times 5. So these are all nice in a row for me, so I'm not going to rewrite it. The 3's are going to be able to buddy up. The 2's and the 5's are not. So because the 3's buddied up, one got to escape, but the other one died. And then the 2 and the 5 are both still stuck inside jail, so we're going to take 2 times 5 to get 10. So our answer is 3 root 10. And just a real quick way that you can check your answer, if you square the outside, so 3 squared is 9 times 10, it'll always get your answer. So you square the outside and multiply it by the inside, and you should get what you started with. So that's just a quick way to check these. So that's all we're going to do for nice whole numbers. We're going to do a second video where we're going to add in some variables with our whole numbers.